Rahim. Assalamualaikum everyone. This is Nakcholi and I have my group mate Abdullah Ilyas along with me. Our project title is Design and Development of Soft Robotic Kit for Educational Training. This project is supervised by Dr. Afaq Manzoor and our co-supervisor is Dr. Mohammad Wakas. You can see from the title of our project that says something about soft robotics. So before jumping into the discussion of our project, first of all, I would like to give an overview of this field of this subfield of soft robotics, that is that is soft robotics. So soft robotics is a subfield, as I have said, that it is the subfield of robotics. Actually, robotics is a broader term, and one of its subfield is soft robotics that concerns with the development and design of robots which are made up of flexible and compliant materials, right? In contrast to rigid-bodied robots built from metal and ceramics and hard plastic, the compliance of soft robots can improve their safety when working in close contact with humans. As if you compare the conventional robots with soft robots, this is one of the advantages of soft robots, that the safety measures is increased in terms of soft robots. Why soft robots? The main goal of soft robotics is to design and construct robots with physically flexible bodies and electronics, right? So the softness can be limited to a part of a machine, or for example, a rigid-bodied robot arm can have a manipulator, can have an end effector made of some kind of soft or flexible material. Soft robots have a tremendous potential, as their flexibility allows them to squeeze into places where rigid bodies cannot, right? Which could provide useful applications in disasters and other relief scenarios. Soft robots are also safer for human interaction and for internal deployment inside a human body. That's again one of the advantages of soft robotics. So soft robotics in education. Soft robot is, as I have said, that is one of the subfield of robotics. Soft robot is one of the fastest growing fields in the robotics community, and it is promised to revolutionize the robotics in society and industry is becoming clear despite the critical applications and use. This research field is quite young right now, because several different technological components and disciplines are involved in soft robotics education, soft robotics education actually, which represent a significant challenge. There are no existing teaching methods that could that cover the entire range of related knowledge. Because most of the existing approaches focuses on robots with fixed morphologies and rigid structure that we also call the conventional robots. So soft robotic kit for educational purpose, right? The soft robotic aims to lower the barrier of entry for a student to participate in STEM by developing a line of soft robotic activities and making them available to different level of student. The students may be of undergrad or maybe school level or college level. Now, if we particularly look into the deep detail of our project has mainly two main things in our project. One is the pneumatic controller, and second one is a set of soft actuator, right? So how this project is aimed for educational purpose, right? Because there will be some students who will be programming this pneumatic controller, and by using that pneumatic controller we will have some actuations in these actuators. So depending on the shape, on the parts of these actuators, the students will program this pneumatic controller, and the pneumatic controller will run these soft actuators. So the problem statement of our project is are these: lack of accessible and comprehensive educational resources for learning soft robotics, and limited availability of practical hands-on experiences for students in the field of soft robotics, absence of user-friendly tools for teaching and experimenting with soft robotic concept, right? This is one of the most important thing that I want to emphasize on this point. Right, in our labs, in our laboratories where we do experiments, where we study robotics, we don't have these kits, these tools and equipment for experimenting or for testing any kind of soft actuators, right? So if you have some kind of soft actuators, the second thing is that you must have a controller, pneumatic controller, to control that soft actuator, the actuations occurring in that actuators. And another thing is need for a versatile platform that integrates the software and the hardware for practical soft robotic education and challenges in controlling and actuating soft robotic component efficiently and accurately. Requirement of user-friendly interface for remote control and monitoring of soft robotic devices, right? This is again one of the important point over here. In our project, we have tried to implement a software strategy for controlling this pneumatic controller, right? Scarcity of affordable soft robotic kits that cater the need of both educators and learners. Here are the aims and objectives of our project. The project aims to develop a versatile and user-friendly soft robotic kit. Actually, the kit will contain two main parts, as I have said earlier, a pneumatic controller and a set of soft actuators that enable the practical learning and experimentation in the field of soft robotics, and to design to cater to learners of different levels, from beginners seeking an interaction to advanced enthusiasts exploring complex concepts. This kit seeks to engage and empower the individuals in their soft robotic journey. And another thing is the soft robotic toolkit aims to lower the barrier of entry for students to participate in STEM, right? By developing a line of soft robotic activities and making them available to students. Students can get started with programming robot of their own design, right? There may have a variety of soft actuators. It's not hard and fast that the student must have only those robots which we have created in our project, right? Students may have different kinds of soft actuators. The soft actuators may have different parts in case of our students, all right? So students will program the pneumatic controller accordingly. For example, if a student have a soft robot that has 5 legs, and he wants to give a different actuation in those legs, then he has to program the pneumatic controller accordingly, right? I mean to say that there could be a variety of soft actuators. So the kit consists of two main things, that one is the controller and another part is the soft robot, right? Over here you can see a pictorial view of our project. There will be the pneumatic controller and there will be a set of soft robots. The pneumatic controller will be programmed by students and educators according to the actuations that we are looking for from these soft actuators. There will be the programming in this in PC, and the program will run in the microcontroller of this controller, and then there will be the actuations accordingly. How this kit will be used in academia. So students, with help of the pneumatic control, can play and learn with different software, right? So students, first of all, student will decide and student will think that what kind of soft robots, what kind of design they are going to have, right? After having an idea, of what kind of soft robots they are going to develop, the second step is to design the mold, right? I will explain in the next coming slides that how the design of molds are there in this project. So alright, from designing the mold for the actuators and controlling the robots by programming the controllers, students will be learning. Actually, students will be designing these molds, and then they will be fabricating these soft actuators, right? After having a set of these soft actuators, students will program the controller according to the shape, according to parts of these soft actuators, right? So pneumatic controller for soft robots. The soft robots are actuated by means of a guided fluid. In our project, we have designed the controller for air as the medium of actuation, right? So if we talk about the actuations occurring in the soft actuators, What kind of actuations are there? The mechanical actuations is there because of a guided pressure. Here the guided pressure may be of a liquid or of a gas as well, right? But in our case, the controller is designed for controlling air, and using those air pressure we are actuating different kind of soft actuator, right? In this block diagram you can see that this input signal will be provided from the app. We have an application for controlling the pneumatic controller, right? From there will be the input, and the input will be into the controller. The controller will control the air, vacuum pump and valves, right? Simultaneously, and then ultimately there will be the actuations in the soft actuators. So the pneumatic controller, here is the rough and the initial stage of our controller. The deformation in the soft robot is made by controlling the positive and negative pressure of the pumps, right? There will be two pumps. One pump is will be there for creating a positive pressure. The air pressure will be inserted in the soft robots, and there we need another pump to extract those air from the soft actuators, right? So there will be different functionalities according to the program that we are going to run in this controller. The pneumatic controller is the heart of the soft robots. This is the key component that gives life to the soft robot, right? So the actuation in this soft robot will be happen because of this guided pressure, because of this controlled pressure. A software control strategy for regulating the amount of internal positive and negative air pressure inside the pneumatic soft board is presented and can be integrated into any specified robotic actuators requiring pneumatic actuation. For example, bending, triangular and muscle actuator, right? There, as I have said, that there could be different kind of actuators, and those actuators will have kind of actuations according to the program that we are going to run in this controller. So here is the construction of pneumatic controller. We have a tubing system. This tubing system is 6 mm diameter, and these tubes are there for carrying air pressure from the pumps to the valve, and from the valve output outlets to the soft actuators. We have array of valves. We have 4 valves in our pneumatic controller. 4 valves actually over there, which are the output from where we get guided and controlled pressure, right? And we have used a ESP 8266, and there is the positive pump for positive pressure, for creating pressure, for inserting the pressure, and there's another pump for extracting pressure. And we have used a relay module for controlling this array of valve, and we have used the H-bridge LN298N for controlling these 2 pumps, right? And we have fixed those pumps in a frame like this. All right, so over here is a clear block diagram of our pneumatic controller system. The MCU is the controlling both the valves and the pumps. Actually, the microcontroller unit is controlling both this area relay and this H-bridge, and ultimately this H-bridge is controlling this pump 1 for pump 1 and pump 2 means pump for creating inserting pressure, and the second pump for extracting the pressure from the soft actuators. And at this point, the microcontroller unit is controlling this relay modules, and these relay modules are controlling the valves, right? Each valves take 10 volts, while the pumps need to have 9 to 12 volts power supply for working, right? The valves are controlled by the MCU by the relay, and the pumps are driven with the help of H-bridge, right? So here's a testing of the pneumatic controller in the very beginning stage. You can see we have this pneumatic controller, and right over there we are testing this controller by using the serial monitor. We don't have the application at that moment. All right, now Pneumatic controller for controller by Harvard by Design Lab. This is the pneumatic controller that we have followed and we have tried to replicate actually. But the main difference between this controller and the controller that we have built in our project is that this controller is actually manually controlled controller, right? Here we have here we have different switches and different potentiometers for controlling the speed, controlling the amount of air which is inserting and extracting from the software boards, and here are keys for switches for controlling the valves, right? So over here they have used pressure sensor as well, valves and switches and potentiometers, power regulators, pumps and microcontroller and MOSFETs. For switching we have used relay, they have used MOSFETs, right? Now in the second stage of this project, we have to fabricate a set of soft actuators, right? For the fabrication of soft actuators, first of all a 3D design of specific robot is needed. We have to make 3D design of our desired soft robot, then print them that design using 3D printer facility at our fab lab, right? And then in the next stage we have the molding and the casting stage. In the molding and the casting stage, the material is spread or poured into the mold of the organism or object to make a final 3D print. We have some videos of this molding and casting stage as well in the coming slides. And in the next step we have to, once we have these 3D once we have these actuators, soft actuators, the third part is to program the pneumatic controller, right? The software boards, we have to program the controller to make certain actuation by software boards, right? And then now according to the program, different parts of the robots will actuate as we have directed the controller to do, right? So here we have the soft robot fabrication step. In the soft robot fabrication, we have different steps. In this step number 1, design the mold of the bending actuator in SolidWorks, right? Because in our project we have decided to make 3 soft actuators. One is this bending actuator, second one is gripper using these using these legs again, and then we have soft actuator that is supposed to be example of crawling in certain actuations, and this chamber will be glued with once we click on this button, gripper button, the controller will work automatically to grab something using a actuator. Another thing is the bending actuation that I have just shown you in the previous slide. Once we click on this, there will be a bending action using one or two valves of the pneumatic controller, and there will be crawling your robot, right? Over there, the student will paste their functions of controlling different soft actuators, right? This is the most important step in this GUI. Student will place their own code over here, and they will have their own robots functioning, right? And then we have a stop all button. There could be any operation, any kind of robots will be running using the pneumatic controller, and if you want to stop those operations occurring on this pneumatic controller, then we have to click on this stop button. We have to set an IP, right? We have to set an IP like this. We have to write the IP over here, and then click on this button, and then we will have connected application with the pneumatic controller. In the software implementation, another step is the coding logic of the pneumatic controller. The logic is that each button on the GUI is linked with the specific function written in C programming, right? For example, if the bending button is clicked, the associated function will be called, and the pressure at the valve's outlet will be specific pattern such that there occurs a bending actuation, right? That I have just discussed in the previous slide as well. And in the results and achievement, we have this product, like we have this pneumatic control system for software board. No matter what kind of software board you have, how many parts are there, actually the parts are limited, right? We have to keep in mind that we have only 4 outlets, 4 valves. That means we are going to control 4 parts of a software board simultaneously, right? We have to keep that in mind. And here is the power rating of our controller. We are using ESP8266, which is taking 2.3 volts, and relay modules 5 volts for the power, and HV is 12 volt, and pumps are taking in 12 volts, and the pneumatic valves are working on 10 volts. So well functioning. The sensors will tell the pneumatic control system that this is the point where I want to go, this is the point where I want to stop. According to that feedback system, it will work like that. PWM enabled valves for more control and precise deployment of pressure. Right now in this project, in this pneumatic control system, the air is not the quantity of air that is inserting inside the soft actuator is not controlled. There will be the whole air will be distributed among the 4 valves of the controller, and those air will be inserted into the software board. So in future we can use the PWM enabled valves, which will enable us to put a certain quantity of air into a certain part of a soft actuator. Included all the main points of our project in this poster, and we have tried to include all those graphics as well in this poster. Here we have these images, our final product, and this is the main concept of our project, and the problem statement as well as the methodology and proposed solutions are also there. We have mentioned our achievement as well in this poster. This is the complete outlook of our poster that we have presented in our exhibition as well. So that's all about our presentation. I hope you all enjoy this presentation, and don't forget to subscribe and follow our channel. Thanks for watching.